Measurement plays a vital role in the study of physics. Do you know in which quantity length is measured? Yes, length is measured in kilometer. Good, but the standard unit of length measurement is meter. But teacher, why do we need a standard unit in each quantity? We use a standard unit to measure a quantity internationally and globally. Let's learn more about the units of measurement and concerned topics. At the end of this lesson, the students will be able to understand units and measurements, understand measurement of length, measure mass, measure time, understand the precision of instruments, analyze errors, explain significant figures, write the dimensional formulas and equations, understand dimensional analysis. Measurement of a physical quantity requires a standard in the form of which that quantity is to be measured. Numerical value that represents how many times that standard has come in the physical quantity. Units are classified in two categories. They are fundamental units and derived units. The units of fundamental or base quantities are called fundamental units. Base quantities are time, mass, distance, electric current, thermodynamic temperature, amount of substance, and luminous intensity. The units which are derived from fundamental units without involving any numerical value are called derived units. For example, units of velocity, area, volume, etc. Look at the definitions of fundamental quantities carefully. Internationally, 4 systems are used for length, mass and time. MKS, meter kilogram second, CGS, centimeter gram second, FPS, foot pound second, SI, International System of Units, SI, International System of Units. The units of all physical quantities can be obtained in SI system of unit. Have a look at the base quantities, SI units and their symbols. Use meter scale, vernier caliper, screw gauge, etc. for the measurement of length. Measurement of length. We use some indirect methods for measuring large distances and measuring very small distances. Parallax method. Parallax method is used to measure the distance of distant object. Parallax is the apparent change in the position of an object due to a change in the location of the observer. Let us observe a star from 2 different positions A and B on the Earth, separated by a distance AB equal to B. The distance between the 2 points of observation is called the bases. Let the bases be B and the total angles subtended by 2 different positions A and B are θ1 and θ2 respectively. Here angles are in radians. From geometry, the angle subtended is equal to arc divided by radius. Therefore, θ1 plus θ2 is equal to AB divided by AX. This gives AX equals BX equal to AB divided by θ1 plus θ2, or AX equal to BX equal to B divided by θ1 plus θ2, where θ1 plus θ2 is equal to θ. Measuring very small distances, we can measure a very small size like that of a molecule using special method. Let us discuss a simple method for estimating the molecular size of oleic acid. Oleic acid is a soapy liquid with large molecular size of the order of 10 raised to the power of -9 meters. First, form a monomolecular layer of oleic acid on water surface. For that, we dissolve 1 centimeter cube of oleic acid in alcohol to make a solution of 20 centimeters cube. Then take 1 centimeter cube of this solution and dilute it to 20 centimeters cube using alcohol. So the concentration of the solution is equal to 1 upon 20 times 20 cubic centimeter of oleic acid per cubic centimeter of solution. Now lightly sprinkle some lycopodium powder on the surface of water. The oleic acid drop spreads into a thin, large and roughly circular film of molecular thickness on water surface. After that, measure the diameter of the thin film to get its area A. Suppose we have dropped n drops in the water. First, we determine the approximate volume of each drop, V centimeter cube. Volume of n drops of solution is equal to nV centimeters cube. So, the amount of oleic acid in this solution is equal to nV centimeters cube. This solution of oleic acid spreads very fast on the surface of water and forms a very thin layer of thickness T. If this spreads to form a film of area A centimeters square, then the thickness of the film is T is equal to volume of the film upon area of the film. That is, T is equal to NV over A centimeters. Range of lengths. In universe, the size of the objects vary over a very wide range. The size of the objects vary from 10 raised to the power of minus 14 meters to 10 raised to the power of 26 meters of the extent of the observable universe. We can use certain special length units for short and large lengths. These are 1 Fermi equals to 1 F equals to 10 raised to the power of minus 10 meters. 1 astronomical unit, average distance of the Sun from the Earth, equals to 1.496 times 10 raised to the power of 11 meters. 1 light year equals to 9.46 times 10 raised to the power of 15 meters. Distance that light travels with velocity of 3 times 10 raised to the power of 8 meters per second in 1 year. 1 parsec equals to 3.08 times 10 raised to the power of 16 meters. Mass of a body is defined as the quantity of matter contained in a body. The mass can be determined to an accuracy of 1 milligram. Digital balances are used to find the mass very accurately. Masses of planets, stars, etc. can be measured by using gravitational method. Mass spectrograph is used to measure small masses of atomic or subatomic particles. Any phenomenon that repeats itself can be used as a measure of time. The measurement is based on the counting of repetitions. The unit of time in all the systems of units is second. Some techniques to measure time interval are given as electrical oscillators. These use an alternating current supply of frequency 50 Hz. The rotations of a synchronous motor run on this alternating current are used to obtain a time scale. Electronic oscillators. Electromagnetic oscillations of very high frequency are produced by a semiconductor device. The small time period of such oscillations can be used to measure small time intervals. Quartz crystal clocks. A quartz crystal shows piezoelectric effect. The oscillations produced can be used to measure time intervals. Atomic clocks. These clocks make use of periodic vibrations taking place within the atoms. Radioactive dating. This technique is used to measure long time intervals by noting the ratio of the number of radioactive atoms which have undergone decay with the passage of time to the number of surviving atoms. Carbon has been used to estimate the age of fossils. All measurements are made with the help of instruments. The result of every measurement by any measuring instrument contains some uncertainty. Error in a measurement is defined as a kind of uncertainty. Error is equal to true value minus measured value. The accuracy of a measurement is a measure of how close the measured value is to the actual value of the quantity. Precision tells us to what resolution or limit the quantity is measured. Errors are of two types: systematic errors and random errors. Error arising due to a defect in the measuring device is systematic error. Systematic errors are of three types: instrumental errors, imperfection in experimental technique or procedure, and personal errors. Instrumental errors. These errors arise due to imperfect design or calibration of measuring instrument. Imperfection in experimental technique or procedure. The errors due to experimental arrangement, procedure followed, and experimental techniques are called imperfection errors. Personal errors. An error due to faulty procedure adopted by the observer is called a personal error. Personal error comes into existence due to making an error in reading a scale. Random errors. The error produced due to sudden change in experimental conditions is called a random error. For example, sudden change in temperature, change in humidity, fluctuation in potential difference voltage. The smallest measurement that can be measured by the measuring instrument is known as least count. The least count error is the error associated with the resolution of an instrument. A measuring instrument cannot measure anything whose dimensions are less than the magnitude of the least count. Least count of vernier caliper is 0.01 centimeter. Least count of micrometer screw gauge is 0.001 centimeter. Absolute error. It is the magnitude of difference between the actual or mean value AT and the individual values AM of any quantity. Absolute error is denoted by delta A. Therefore, delta A is equal to AM minus AT. Relative error. It is defined as the ratio of the mean absolute error delta A to its actual or mean value AT. Therefore, relative error in A is equal to delta A over AT. Percentage error. It is the product of its relative error with 100. Therefore, percentage error is equal to delta A over AT times 100. There are three basic forms for combination of errors: error of a sum or a difference, error of a product or a quotient, and error in case of a measured quantity. Error of a sum or a difference. When two quantities are added or subtracted, the absolute error in the final results is the sum of the absolute errors in the individual quantities. Error of a product or a quotient. When two quantities are multiplied or divided, the fractional error in the final results is the sum of the fractional errors in the multipliers. Error in case of a measured quantity raised to a power. The fractional error in a physical quantity raised to the power is the power times the fractional error in the individual quantity. Significant figures in a measurement are defined as the known digits in that measurement. Number of significant figures in a measurement represents the level of its accuracy. Let us take an example. 2.000 centimeters is the most accurate as it has 4 significant figures. To get rid of ambiguities in deciding the significant figures, we use scientific notation in the power of 10. For example, 5.300 meters have 4 significant figures. If we change units, 5.300 meters into 5.300 times 10 raised to the power of 2 centimeters. The power of 10 is irrelevant to the determination of significant figures. So, it still has 4 significant figures. Rounding off. It is a process by which number of significant figures can be reduced as per requirement. Let us take an example. L is 3.6587 centimeters. On rounding off, we get the value of L as 3.659 centimeters. Dimensions of a physical quantity are the powers to which the fundamental units have to be raised to express the unit of that physical quantity. All the physical quantities can be written in terms of the dimensions L, M and T. The dimensional formula of a physical quantity is an expression within a squared bracket in terms of fundamental units with their powers. Let us take an example. The dimensional formula of force is mass times acceleration, which is equal to m1 L1 T minus 2. Dimensional equation is an equation which is obtained by equating the dimensional formula of a physical quantity with its symbol. The magnitudes of physical quantities may be added together or subtracted from one another only if they have the same dimensions. Uses of dimensional analysis to convert a physical quantity from one system of unit to another. To convert a physical quantity from one system of unit to another, to check the correctness of a given physical relation, to establish a relation among the given physical quantities. Let us summarize what we have learned. The International System of Units SI, based on 7 base units, is at present an internationally accepted unit system and is widely used throughout the world. Parallax method is used to measure the distance of distant objects. The SI units are used in all physical measurements for both the base quantities and the derived quantities obtained from them. Physical measurements are usually expressed for small and large quantities in scientific notation with powers of 10. Mass of a body is defined as the quantity of matter contained in a body. Direct and indirect methods can be used for the measurement of physical quantities. While expressing the result of measurement, the accuracy and precision of measuring instruments along with errors in measurements should be taken into account. Dimensional analysis can be used to check the dimensional consistency of equations, deducing relations among the physical quantities, etc.